Section number 20 is entitled Distance Problems. And just like all our earlier problems, the last few sections, the word problems, we're going to multiply two quantities and get a result. Before we multiply the price per pound of the peanuts by the number of pounds we bought. The concentration in their liquid, in the container, by how much is in the container. 20% alcohol by 50 gallons. Now we're going to multiply rate times time, and we're going to get distance. And this does seem to make sense. For example, if your rate of speed is 30 miles per hour, that's your rate, and your time is maybe you drive or run or what have you for 2 hours, just like numbers and variables, units cancel out. Hour in top, hour in the bottom. And what you're left with is 30 times 2, which is 60, believe it or not, times miles. Just like when we write 3x, we don't have to write 3 times x. When we write 60 miles, we don't have to write 60 times miles. And nonetheless, we went for 60 miles. 30 miles the first hour, 30 miles the second hour. We are doing 30 miles an hour for a grand total of 60 miles. Okay, so let us try this word problem. Suppose you always get up late for work, that if you leave late for work, you have to speed. You're driving to work. And suppose that it takes you 2 hours to drive to work. And using the same route, it takes you 3 hours to drive home from work. Okay, to save space, I didn't write using the same route. But using the same route, going to work is coming home from work. And you come to know that you know that this person drives 20 miles an hour faster going to work. You drive 20 miles per hour faster going to work. How fast do you go to work and how fast do you come home from work? How about we say it takes your friend. It takes your friend. Your friend drives 20 miles per hour faster going to work. How fast does your friend drive to work? How fast does your friend drive home from work? If it's you, you have every right to say, well, I'm not a fool. I know how fast I go to work. I know how fast I drive home from work. But you come to know that it takes your friend 2 hours to drive to work. Why? Because you know your friend starts at 9 o'clock, and every morning you see your friend leaving at 7 o'clock. And you know your friend gets off of work at 5 o'clock, and she's home by 8 o'clock. So you conclude it takes her 3 hours to get home. Okay, rate times time is distance. Well, you don't know the rate that she drives home. You don't know the rate that she drives to work. So one of them you call R. And you know that she drives fastest to work. If she drives R miles an hour home from work, she drives R plus 20 to work. She drives 50 miles an hour coming home, she drives 50 plus 7, 20 going to work. If she drives 25 miles an hour coming home, going to work, she drives 25 plus 20. The time it takes her to get to work is 2 hours, and home from work is 3 hours. What's the distance? Well, rate times time, or time times rate is distance. That's how far this person drives to work. How far does this person drive home from work? R times 3, or 3R. But they take the same route. That is, these distances are equal. So I take the first distance, I put these two horizontal lines, and then I write down the second distance. The distances are equal. 2R plus 40 is R. Well, if I ask you 2R plus what equals 3R, you should tell me R. That is, I already know R is 40. If you can just see that, great. 2R plus 40 is 3R. Well, then R is 40. Because 2R plus R is 40 is 3R. 2R plus R is 3R. So R and 40 are equal. If you don't accept it as that line, well, do some more work. Take away 2R from both sides, and you get just what I said. R is 40. So she goes home at 40 miles an hour, and 40 plus 20 is 60. She drives to work at 60 miles an hour, drives home 40 miles an hour. And we can check this. 3 times 40 is 120. 40 plus 20 is 60. 2 times 60, what do you know? 120. Both cases, she drives 120 miles. And it should be the same distance. They're taking the same route to and from work. She's taking the same route to and from work. Same route, same distance. I mean, come on. If it takes you 20 miles, if it's 20 miles to go to work, you should know that you drive 40 miles per day. Of course, we're assuming you go straight to work and straight home. You drive 40 miles a day. You don't have to wait till you get home to check your odometer. You know that it's going to be 20 plus 20. Okay, next problem. You have somebody on the shore. Okay, you have somebody standing on the ground, and the ground is not moving. And this person is watching the water, which has a current. There's a current because it's on a hill. Okay, and there's a boat. There's a boat. Now, if the current is, say, 2 miles an hour, well, first, what does that mean? That means in this direction, the water is moving 2 miles an hour. That is, if nobody's in the boat, there's no motor in the boat, nobody's rowing the boat is just in the water. Well, right now it's here, and an hour later, it will be 2 miles away. It moves 2 miles an hour. The water moves. And the boat being underwater, it moves. You ever been in the airport where they have the walkway that moves? Well, if you're standing on the walkway and the walkway is moving, well, so are you. Assuming you're not walking backwards. If you're just standing there, well, you're moving, you're making progress. You started here, and at some point you'll be there. You're making progress, you're moving. What rate are you moving? Well, it depends upon the speed of the walkway. Maybe it's moving at the rate of 7 miles an hour. Okay. So you know the boat is moving down the stream, downstream, at the rate of 2 miles an hour. The water always goes downstream. Okay. Now, if somebody in the boat causes the boat on its own, whether they're rowing the boat or they have a motor pushing the boat, but the boat is going 10 miles an hour. How fast is the person going in that direction? The answer is 10 plus 2, 12 miles per hour. When you're going in the direction of the current, that is when you're going downstream, you add. If, on the other hand, the person was going upstream, well, in an hour, they moved their boat 10 miles. But the current, the water, went back 2 miles. So this person will look at the boat an hour later and say, oh my, the boat only went 8 miles. It would be 10 minus 2, or 8 miles per hour. When you're going downstream, you add the current. Remember, the current was 2. When you're going upstream, you take your speed and you take away the current. Either you add the current or you take it away. If somebody's on a walkway and the walkway is going in this direction 7 miles per hour, and for some reason they're on the walkway when they go in the other way at 10 miles per hour, if the walkway is fairly long, in 1 hour they will, as far as this guy goes, in 1 hour they will be right here, 3 miles away. And another hour, they'd be another 3 miles away. Okay, you subtract. If you walk in the direction of the walkway, you add. If you walk in opposite the direction of the walkway, you subtract. If the walkway is going this way and you walk that way, well, it depends. Now this becomes, let's not talk about this because it becomes 2 dimensions. If you start off here, in a little while you'll be here. The walkway brought you to the right, but you walked up forward. So let's not talk about that. Okay. So, what did you learn about the boat problems? You take your speed, and if you're going upstream, you take away the current speed of the current. Is your speed minus the speed of the current. Your speed, the speed that you're moving on your own, is called the speed of the boat in still water. What would if the water wasn't moving, your speed would be the speed that somebody sees you moving in still water. Okay, so you come to know a boat travels for 4 hours downstream. And on the return trip, it takes 5 hours upstream. They go on the same route. First they go downstream, then they go upstream. Distance is the same. If you come to know that the current of the water is 3 miles per hour, then how fast is the boat going in still water? How fast is the boat going on its own, without the help of the current, or without the hindering of the current? How fast is the boat going? That's the question. Well, this is a distance problem, or a rate times time equals distance problem. You have rate times time is equal to distance. And you have upstream and you have downstream. You have the rate, the time, the distance. It takes 4 hours to go downstream. Excuse me. It takes 4 hours to go downstream and 5 hours to go upstream. Now, we'll say the route of the boat in still water is off. So going upstream, you take away the speed of the current. Going downstream is helping you. You add the speed of the current. And your distance will be time times the rate. 5 times r minus 3. This times that, or that times this. 4 times r plus 3. Now what you know is the distances are equal. 5r minus 3, 5 times r minus 3 is 4 times r plus 3. So it's 5r minus 15. 5r minus 15 is 4r plus 12. 4r plus 12. Let's copy that down here, please. 5r take away 15 is 4r plus 12. I'm going to bring all the r's to the left side by taking away 4 of them on the right side. By taking away the r's on the right side. I'm going to take away 4r from both sides. And I want numbers to only be on the right-hand side. I'm going to add 15 on the left side so it cancels out. And I have to add 15 on the right side. So r, the rate of the boat, or the speed of the boat in still water, is 27 miles per hour. 12 plus 15 is 27. So since I asked you how fast is the boat going in still water, you really should have said that. In still water. The answer will be 27 miles an hour. If they say upstream, 27 minus 3 is 24. Downstream, you add the 3. It's going 24 miles an hour upstream, 30 miles an hour downstream. It looks like it's working because 24 times 5 is 120, and 30 times 4 is also 120. It should be going the same distance upstream and then downstream. Okay, that's how you do that problem. Let's try another distance problem. Suppose you and your friend are going to start at point A and go to point B using the same route. Okay. You leave at 12 p.m., 12 noon, from point A. From point A. Your friend leaves point A 2 hours later at 2 p.m. and catches up to you because she's driving faster. And catches up to you at 5 p.m. exactly as you reach point B. Point B. And you are traveling at, say, 65 miles per hour. The question is, how fast is your friend traveling? Okay, so you have you and you have your friend. And you know everything about you. Rate times time equal the distance. You know that you're going 65 miles an hour, and you leave at 12 o'clock, and you get to point B at 5 o'clock, just as your friend catches up to you. So you're going for 5 hours. 5 times 60 is 300, plus 5 times 5 is 25. 300 plus 25 is 325. Now you're a friend. You have no idea how fast your friend is going. Now, how long of a time is your friend driving for? Well, she leaves at 2 o'clock from point A and gets to point B at 5 o'clock. Your friend drives for 3 hours. And went, well, 3 R miles. R times 3. But we know that these are equal. We know that these are equal. We know that 3R is equal to 325. So we divide by 3, we divide by 3. And R is, well, if you do the long division, 3 into 325, you'll get 108 and a third. So your friend is driving at the rate of 138 miles per hour. That is how fast she is driving. She's speeding. You're doing the speed limit, 65. Your friend is doing a bit more, 108 and 1/3 miles per hour. That way, in 3 hours, 3 times 108 and a third will equal 325. And that's why she caught up to you, exactly at that instant at 5 p.m. Okay, I hope you start seeing the similarities between all these word problems. If you're not, you need to do more. You multiply 2 things and you get a result. That's what you do with all of these problems. Okay, good luck with them.